Hello, my name is Kermell Huertas. I'm going to show you how to do a calculus problem. The problem says that we have our normal xy, and there's a point 2, 5. X equals 2 and y equals 5. It's telling us that there's a line that passes through this point, and it forms a triangle with the x-axis and the y-axis. In any case, this line could pass with any slope through this line, and it would still give us a triangle unless it's perpendicular to the x-axis. So as long as it doesn't do that, it's going to form a triangle. What the problem is asking us to do is to minimize the area, the possible area that this triangle will have, with the slope find the slope that will give us a minimum area, basically. So how do we do that? First of all, we have our area function, half of the base times the height. We don't know what's the base or the height, but we do know that this forms a little square in which this equals 2 and this equals 5, and that forms a rectangle and two little triangles. In order to find the area of the whole triangle, we can have a ratio between the little triangle and the rest of the triangles. So let's just use this one as reference. So let's say this is 2, and then this is x. So we'll call this x. Same as this. This is y. This is 5. This is y. Let's just call this y. All right. So our little triangle is going to be 5 high, right? Let's do it this way. It's going to equal y over 5, and going to equal 2 over x. That means that the ratio between the y and the 5 is going to equal the same as 2 to the x. And we do the multiplication, it's going to equal 10. And with this, we can actually select a variable. So let's say I want my y. So I want y equal 10 over x. Alright, so now we have to assign a value for the entire length of the triangle, entire base of the triangle. So we already know that we assigned y and x to it, so let's just call this entire length our y plus 5, and this entire length our x plus 2. Perfect. So let's just substitute in our area function. So a is going to equal half of base, which is x plus 2, times height, which is y plus 5. Now, in order to have it in terms of x, we already substituted for y, so we're going to change y to 10 over x. And with this, we can start differentiating. So let's just let's make this into a simple function. This is going to be x plus 2 times 10 plus 5x over x. I just multiply this x over and down, so it'll have the same function. By a half, of course. We keep going down. X plus 2, exactly. So I just assigned this to the half. I just put it here, so it'll be easier. And now we can just multiply these together, and we can multiply the top halves together. So it's going to equal something like 5x squared plus 20x plus 20 over 2x. This is basically our main function for area as of now. And in order to find minimum area, we're going to have to differentiate this equation. So let's go over here. Let's say this is our f of x, or even a of x. Okay, so now our a prime of x is going to equal 2 2x, because it's the bottom one, times top half differentiated, which is going to equal about 10x plus 20 minus 5x squared plus 20x plus 20 multiplied by 2, there it is, over 4x squared, which is 2x times 2x. Now, you just use a distributive function. It's going to equal about 20x squared plus 40x minus 10x squared minus 40x minus 40 over 4x squared. And we can still keep simplifying. The 40s cancel out, and these actually go down, so it's 10x squared minus 40 over 4x squared, which again simplifies into 5x squared minus 20 over 2x squared. Now this is our derivative for area. And if you know about the asymptotes, you're going to notice that they have the same polynomial function. So it means that the slope of this function is going to equal the coefficient of the top half over the coefficient of the bottom half. So it means it's 5 over 2. And if you want proof of that, I can still give you proof of that. If we put that 5x squared minus equals 20 top half, we're just going to equal 0. Going to divide by 5, so x squared equals 4, so x equals plus minus 2, and because 2x squared is also one of the limits, we're going to put it 2 as in, wait no, it's wrong. It can't equal 0, exactly. So, alright, we're going back to our original triangle. We know that a equals y plus 5 and x plus 2. Of course, our distance can't be negative, so we just take this out, and we know that our x is going to equal 2. So we just substitute it here. 2 plus 2. So it means this length equals 4. And we substitute it here, y, and what did y equal? Y equals 10 over x. So 10 over 2 equals 5. So it means that this distance equals 5. And, oh wait, sorry, equals 10. 5 plus 5 equals 10. We got 10, 4. We find the slope this way. It goes down 10y, and it goes across 4, so it means it's 10 over 4, which, as I said, equals 5 over 2. So it means this is our slope for this line. And this slope is going to minimize the entire area of the triangle. And yeah, that's basically it.